Hello GATE aspirants, welcome to part 3 of GATE electronics series. Question 4. If the peak output voltage of a full wave rectifier is 10 volt, its DC voltages, so VDC is equal to 2 Vm upon pi, where Vm is the amplitude of that voltage, that is peak voltage. So this will be 2 into 10 upon 3.142, and this is equal to 6.36 volt. So option C is correct. Next, question 12. A germanium semiconductor is doped with acceptor impurity concentration of 10 raised to 15 atoms per centimeter cube. For the given hole mobility of 1800 centimeter square per volt second, the resistivity of this material is. Now resistivity is equal to 1 upon conductivity, and conductivity is Ne mu. So this will be 1 upon acceptor impurity concentration into E into mobility, that is 1 upon 10 raised to 15 atoms per centimeter cube into charge is 1.6 into 10 raised to minus 19 into mobility is 1800 centimeter square. So this will be 3.47 ohm meter, because I had not converted it into meter cube, so it will be in centimeters. So option C is correct. Question 15. Identify the correct energy band diagram for silicon doped with arsenic. Here conduction band, valence band, ED and EF are conduction band, valence band, impurity and Fermi energy level. Now Fermi energy level, it lies in between conduction and valence band when there is no doping involved. Whenever there is doping involved, then this EF, it is in between E donor and conduction band. So EF should be in between E donor and conduction band. And if it is acceptor level, then it will be in between acceptor level and valence band. Here none of the options is correct, and this was an empty question, that means marks to all, marks were given to all students. Next, question number 20. Consider the following op-amp circuit. Which one of the following correctly represents output V out corresponding to input V in? Now this is a comparator circuit. V1, this is V1 and this is V2. So V1 is equal to V in and V2 is equal to voltage at this point. The given voltage is 5 volt and voltage across 1 kilo ohm resistance is V2. So that will be 1 kilo ohm upon 1 kilo ohm plus 4 kilo ohm. I am using voltage divider rule into 5 volt. So V2 is equal to 1 volt. So if V in is greater than V2, then the output voltage will be plus 10 volt. See, this is V in. So if voltage given to positive terminal, if it is greater than that given to the negative, that is non-inverting input is greater than inverting input, then output will be plus VCC. And if V in is less than V2, then the output will be minus VCC, that is minus 10 volt. So we have to just check that. So when output is less than 1 volt, input should be minus 10 volt. So when it is less than 1 volt, input is minus 10 volt. So only option A is correct. Question 31. In the following circuit, for the output voltage to be VO is equal to minus V1 plus V2 by 2, the ratio R1 by R2 should be. Now we will consider some cases. Let us assume this V1 is equal to 0. So if V1 is equal to 0, then what will be output? We will try to find it out. If V1 is equal to 0, then according to this expression, output will be V2 by 2. So if V1 is equal to 0, according to this equation, VO will be V2 by 2. Now let us check what will be VO from this circuit. So VO will be, this is a input is given to both V1 and V2, and this is a circuit in which feedback is also given. So the gain will be 1 plus RF by RI, and the voltage at this point will be voltage across this R2 resistance. So that is R2 upon R1 plus R2 into that V2. So this is V2, but voltage at this point is this, and into I have multiplied it by the gain. So that will give us the output voltage. So let us solve this. This will be 1 plus RF is this R upon RI is also R. This is RF and this is R. This is RF and this is RI. And we have R2 upon R1 plus R2 into V2. This is output voltage, but output voltage is equal to V2 by 2. So V2 by V2, that will cancel out. This is 1 plus 1, that is 2. So I'll get 4R2. This will be 2 into 2, that is 4R2 is equal to R1 plus R2. That gives you R1 by R2 is equal to 3. Now let us consider second case. Suppose V2 is equal to 0. Then according to this equation, VO will be minus of V1. But from this circuit, VO will be, then it will become, if VO is 0, if the second input is 0, then it will be a inverting amplifier. And for inverting amplifier, the gain is minus RF by RI. So this will be minus RF by RI into input. Input is given, that is V1. So this will be minus R by R into V1, that is minus V1. So it is satisfying both the conditions, and we have obtained R1 by R2 is equal to D. So option D is correct for this question. Then question number 33. In the following circuit, the voltage drop across the ideal diode in forward bias is 0.7 volt. So its voltage is 0.7 volt. The current passing through the diode is. Now we will use Kirchhoff's voltage law in this equation. Let us assume the current passing through this is I, and current passing through this is ID. So current here will be I minus ID. So let us use Kirchhoff's voltage law in this first loop, this loop. So this will be minus 24 plus I into 12 plus it will be 6 into I minus ID, that is equal to 0. That means 24 is equal to 12I plus 6I minus 6ID. So 24 is equal to 18I minus 6ID. You can write this as 4 is equal to 3I minus ID. So this is equation 1 from loop 1. Now let us write similar equation in this second loop as well. This is the second loop. So this 0.7 volt, it will come across this two. So 0.7 volt minus 0.7 volt minus 3.3 into current ID plus I minus ID into 6, that will be equal to 0. So 0.7 volt is equal to 3.3 ID plus 6 ID minus 6I. So 0.7 is equal to this will be minus 7. So this will be 6I minus 9.3 ID. So we have two equations that we have to solve. Let me multiply this equation by 2. So this will be 8 is equal to 6I minus 2ID. Equation number 3. Let us subtract these two equations. So 8 minus 0.7 is 7.3. 6 and 6 I will cancel out. And minus 2ID minus minus plus 9.7 ID. That is minus 7.3 ID. So from here ID is equal to minus 1 milliampere. It is coming out to be negative because the direction that we had chosen is in the reverse order. So the magnitude will be 1 milliampere. So option B is correct. Next, question number 17. Consider the following circuit in which the current gain beta DC of a transistor is 100. So it is 15 volt, 100 kilo ohm, 900 ohm and 100 ohm. Which one of the following correctly represents the load line, that is collector current IC with respect to collector emitter voltage VCE and Q point of this circuit? So for this we have to find VCE and IC and also the Q point. Now for this VCC, this voltage is across this RB resistance and also this RE resistance. So if I am considering this part, then I can write this VCC is equal to IB RB plus voltage across base emitter junction plus IE RE. And we can write IE is equal to beta into IB. So VCC minus VBE is equal to IB into RB plus beta into IB into RE. So from here IB is equal to VCC minus VBE upon this part, that is RB plus beta into RE. Now this is RE, this is RB and this is VCC, and VBE is given. Even if it is not given, we can take VBE to be 0.7 volt. So substituting these values of RB, RE, VBE and VCC in this equation, we will get IB to be equal to 0.13 milliampere. So that is IB. From here IC is equal to beta into IB and that is equal to IE as well. Beta is 100, so 100 into this, that is 13 milliampere. So IC is 13 milliampere. Now let us consider this path. So for this path VCE is equal to, VCE means voltage across collector emitter junction, that will be equal to VCC minus voltage across collector resistance and emitter resistance. So VCE is equal to VCC minus IC in bracket RC plus RE. Now this is equal to RC. Now we have calculated IE, VCC is known, RC is known, IE is known. By substituting these values, VCE is equal to 2 volt. So VCE is 2 volt. And now we have to find the endpoints as well. So this part, for this equation we have to solve actually. We have this equation, right? So for this, if I want to calculate IC is equal to IC sat, then VCE should be 0. So let us use this equation only. We have this equation VCE is equal to VCC minus IC into RC plus RE. This is the equation. First put IC is equal to 0. That gives you VCE is equal to VCC. And next put VCE is equal to 0. That will give you IC saturation. And that IC saturation is equal to 15 milliampere. Just put here VC is equal to 0, then IC is equal to VCC by ICRE. That comes out to be 15 milliampere. So these are the points, 15 volt and 15 milliampere. So 15 and 15, these are the two options in which we have 15 milliampere and 15, and Q points we have calculated, that is 13 milliampere and 2 volt. So option A is correct. So these were all the questions from GATE 2012 paper. If you like this video, please hit a thumbs up and subscribe to my channel for more videos. Keep learning.